Hi, this is Bruce with Z Group Energy. I'm here on behalf of all my partners over at Z Group Energy, and I'd like to talk to you a little bit this morning, this afternoon, this evening, wherever you are, regarding our exchange chamber and geothermal viability. Now, if we were to investigate geothermal energy applications, say for a university term paper, or maybe just for fun, because isn't that the sort of thing most of us would do with a Saturday morning? Of course we would. And if we were to do that, we might run across US Patent 8381 523B2, which in turn might prompt the question, what is an exchange chamber? What does it do? Why does an exchange chamber, a simple enough sounding device, constitute serious geothermal evolution, progressively carrying geothermal technology cost effectively into and even beyond the 21st century? Now, to clarify, let's briefly digress just for a moment and analogously consider the development of today's highly sophisticated combustion engine. Now, per Wikipedia, the source of all knowledge in the world, of course, the history of steam engines tells us that the first recorded steam engine, called the, if I say it correctly, the Aleopile, was described by mathematician Aaron of Alexandria in the first century AD. That's more than 2,000 years ago. Now, in other words, we know the concept of converting steam pressure into mechanical movement was already known in Roman Egypt as early as the first century, though it wasn't very useful at that time, was it? Now, experimentation continued for centuries, in fact, many centuries, until Thomas Newcomen in 1712 designed the first commercially viable atmospheric engine. That's what Thomas Newcomen called his invention, the atmospheric engine, which was a reciprocating steam device utilizing a cylinder and piston. Now, this fundamental breakthrough was creatively employed in many different ways in many different industries until the 20th century, when it began to be replaced by more efficient steam turbines and, of course, finally, the internal combustion engine. Now, regarding either steam or combustion engines, a single cylinder was a powerful thing, but the real breakthrough, the frosting on the cake, the meat of it, the more significant value and contribution was assembling several cylinders and pistons together within an engine casing. It's the totality of the engine, combining the power of multiple cylinders and pistons, that finally gave birth to today's ultra smooth, incredibly reliable, amazingly powerful, wondrously useful machines. Now, circling back to kind of complete our analogy, Z Group Energy's exchange chamber is our geothermal engine, combining the power of multiple closed heat cylinders into a zero-emission system, a commercially viable geothermal technology. Okay? Now, a single exchange chamber, for example, can combine the power of, say, 10 heat cylinders, okay? Which at supercritical temperatures, that's temperatures above 374 degrees centigrade with water, yield a 3,000 megawatt power plant. What do you think of that? Now, as a side note, Yesterday's geothermal systems, conventional geothermal systems, employ open, that is, perforated wells, both to harvest in situ geothermal brines via the return wells, which they're perforated on the bottom, so the geothermal brines from under the ground can be taken into the well and brought up. Excuse me. And then the underground reservoir is replenished via what is called an injection well, which is also an open, perforated on the bottom type of well. Because if we draw down the geothermal reservoir below ground by extracting the brines, we have to replenish that in order to continually produce electricity using that system. Now, the the Z group energy system, on the other hand, employs closed heat cylinders. They're not perforated. Our closed cylinders can then heat clean water or some other fluid internally. No outside fluids or materials are ever taken into the GEE system from outside the closed cylinders. Since no outside fluids are taken in and no internal fluids are injected below ground, the ZGE system uses the term heat cylinder rather than the more familiar term well. Wells are usually either injecting fluids underground or taking in underground fluids. The ZGE system doesn't do that. Our system is closed. That was just kind of an aside. Now, convective, non-partition flow allows the Z-group energy heating cylinders to be sealed, thereby eliminating the need for and the use of in situ, that is, in place geothermal brines, which can contain corrosive, even toxic contaminants. Now, the enclosed heating system, using water as the heat carrier, makes zero emissions possible. But, as they say, nothing is ever so simple as it looks. Every heat cylinder drilled will provide, at its discharge, heated fluid, but at a different temperature and pressure than any other cylinder that might be close by. Okay? If you have a number of heat cylinders, all deep drilled, all producing heated fluid, each of them will have a slightly different temperature and pressure. Okay? Now, from an engineering standpoint, this variability makes combining these heat cylinders logistically complicated, okay? Now, it isn't necessary here, I don't think, to get into the technical aspects of variable pressure, backflow, regulating valves, control valves, etc., other than just to mention that if the discharges from multiple heat cylinders are to be combined, then the thermal energy with variable discharge temperature and pressure captured and delivered by each individual cylinder must somehow be combined, mixed, and homogenized to provide a safe, consistent, non-variable feed source which enables the steam turbines to safely and reliably do their job. Now, ZGE accomplishes all of this via our patented exchange chamber, which revolutionizes storage of geothermal energy by standing the entire system on its head, so to speak. Our exchange chamber enables the storage of clean, unpolluted water, or some other fluid, to be conveniently held and stored above ground rather than taken from a below-ground reservoir harboring potentially corrosive or toxic brines. The exchange chamber combines multiple, though variable, thermal energy sources, that is heat cylinders, then convectively mixes their discharges, transferring and balancing those variable heated discharges into a homogeneous, dynamically stratified whole, where less dense heated fluid or steam, depending on the pressure in the system, is extracted from the top of the chamber, and cooler, more dense feed water is provided near the bottom of the chamber. Now, multiple cylinders combined via an exchange chamber can drive a 3,000 megawatt power plant, meaning geothermal energy, folks, has entered a new era. This is a significant development. It is very important. Now, to reiterate, closed, non-partitioned heating cylinders make zero emissions possible by eliminating any contact with contaminated below-ground geothermal brines. The exchange chamber then combines multiple heat cylinders, providing an economy of scale which enables zero emissions and makes the whole system commercially viable and very, very cost effective. Now, comparatively speaking, conventional geothermal technology makes use of naturally occurring hot fluid storage below ground. The fluid is harvested via open, that is perforated, return wells, and it's used to drive steam turbines and driving generators which produce electricity and give it to the grid. Now, the below ground reservoir must be replenished naturally or augmented, usually they are augmented, via open perforated injection wells as the in-place fluids are removed from the reservoir, because if we drop the reservoir level by extracting the brines, then over time we reduce the capacity of that reservoir to produce electricity. We don't want to do that, so it has to be replenished in order to keep the underground reservoir productive. Now, these in-place fluids, the geothermal brines, are problematic to work with as they tend to be corrosive, sometimes even toxic, and they require expensive treatment both before and after use. As a matter of convenience and differentiation, if you will, I refer to this technology, the technology that geothermal has been employing since the early 20th century, as the conventional two-pipe, two-well system. I call it that because you need a return well and an injection well and pipes connecting all that stuff. It's a two-pipe system. ZGE, on the other hand, employs what can be called, and I call, a closed single-pipe system, whereby each heat cylinder is filled internally for heating the fluid, discharge, refilling, reheating, discharge again, all in a continuous, convective, non-partitioned heat harvesting cycle, eliminating any need for injection wells and eliminating all contact with outside brines, contaminants, etc. This is all enabled by the exchange chamber. Fracking, incidentally, is also eliminated. Down with fracking, we don't need it. Now, the exchange chamber, located at or near the ground surface, enables combining multiple closed heat cylinders, each conductively taking on thermal energy from below ground hot rock. We don't need the underground brine reservoirs anymore. The ZGE system just needs hot rock. That's all we need. Okay? Then it convectively flows significant quantities of heated fluid up into the exchange chamber, where the heated fluid is stored above ground for clean, environmentally friendly, convenient access. This is a revolutionary way to handle geothermal energy. Nobody has ever done this before, and it is a technology that is now available. So in other words, the exchange chamber tips the entire geothermal heat harvesting process upside down, with storage conveniently above rather than below ground. This permits ZGE's system to utilize clean water or some other fluid, if appropriate, for energy transfer, enabling a zero emissions technology where the only byproduct is H2O, water, nothing more. It should be noted that an exchange chamber can be installed above ground, it can be bermed, it can be partially buried or completely buried. But in any case, it'll be near the ground surface where maintenance and storage is all easily accessed and maintained and operated. Now, ZGE's exchange chamber revolutionizes the way geothermal energy is stored. This is significant because storing electricity, as you probably know, after it's generated is difficult at best. With the most common method, I guess, being dammed hydroelectricity, which actually stores water, not electricity. Now, as you know, electricity is actually an energy flow traveling at the speed of light. You have electrons moving in a flow of energy. That's what electricity is. Electricity is never just sitting there doing nothing, and this makes it difficult to store flowing energy. It's very complex. If electrical energy produced for the grid isn't used immediately, then it's usually wasted, which isn't very cost effective, is it? Power grid operators typically resolve this dilemma by running a mixture for the grid of lower cost base plants, if you will, which run near constant output, a base output, and then they ramp capacity up during demand peaks using usually higher cost peaker plants. That's what they call them, peaker plants. Now, Z Group Energy doesn't propose to expensively store electricity after it's produced either. We don't see any need to do that. Instead, ZGE proposes cost effectively storing clean, hot water, preferably at supercritical temperatures, so that electricity can be generated at any time on demand. Not quite instantaneously, but very, very quickly. This hot water storage ability basically diminishes, even eliminates the need to store electricity, given adequately predictive control systems that are capable of anticipating demand peaks and valleys. And the good news is that this technology is already available. The grid already makes use of very predictive algorithms and so forth to manage power production. For example, they pretty much know what the peak energy demand is going to be the hour before the Super Bowl, say. Now, anyway, if you've been searching clean energy technologies on your Saturday morning or some other time, I hope we've shed some light on a few of the ways that our exchange chamber constitutes an exciting new geothermal innovation. Our system is groundbreaking. It has never been done before. This is something we'd like for folks to take a look at and begin using. Now, if you'd like to know more about ZGE's revolutionary exchange chamber, I'm Bruce. You can email me at my email, bruce@zgroupenergy.com, or you can just leave a comment on any page of our website. You can comment on our Facebook page, and you can comment on our Z Group Energy YouTube channel. So I hope that we've provided some useful information to you. And thank you for visiting us today and for giving us your time. And please have a great day. Bye-bye.